Welcome to Geometry Pre-AP. Today we're going to learn about Pythagorean Theorem and its converse. You might want to pause the video for a minute and record the vocabulary and the essential understanding question. All right, once you have those recorded, let's move into always have your postulate and theorem sheet out when you're working on these videos. All right, so our first theorem today is theorem 10.1, which is Pythagorean Theorem. We've been using this all first semester, so make sure you highlight that theorem. And then it's converse. The converse says basically if you put the numbers into Pythagorean theorem, that when you put the numbers in there, if they work out, then you have a right triangle. So if sides work in Pythagorean theorem, oh, sorry about that, then the figure must be a right triangle. Okay? All right, so these are our two theorems. And like I said, we've been using this for a long time in school. All right, so another little key thing about Pythagorean theorem is Pythagorean triples. We want you to know at least these four. So make sure you have memorized and know these these four Pythagorean triples. All right, and that is 3, 4, 5, 5, 12, 13, and 8, 15, 17, and 7, 24, 25. If you know these four, that'll help you do a ton of things. I used these on you all first semester when I had you doing different things with Pythagorean theorem, and I wanted to come out to be integer numbers. But this is a small list of just four. In reality, I have a huge list of them. Just to give you an idea of the list that I have, how about this? Oops, I didn't mean to do that. Let's delete this off. Here's a nice long list, and that's just maybe 1/10 of what I have on my list. So these are the first four. There's the 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. If you know those four, I'll be happy. Memorize them. I may ask you to write them down on something. All right, so these are two theorems that go with Pythagorean theorem. This one says that if you have a triangle and you take the three numbers for the triangle and your longest number, c squared, is bigger than the a squared plus b squared, which are the two smaller numbers, then you know it's an obtuse triangle. And if the c squared is less than the a squared plus b squared, then it's an acute triangle. So highlight both these theorems. Now, how do I like to remember it? Acute starts with an A, right? So if the A is bigger, it's acute. If the C is bigger, it's obtuse. And that's the easiest way. And if they're equal, it's right. Okay. So move on through here. It says here, what is the length of the hypotenuse of triangle ABC? We know that right triangle, so we can work through this and we can say a squared plus b squared equals c squared. If you want to pause the video and work through this, that'd be great. All right, let's see how you did. First, we delete off this and we plug our numbers in. How do we know where the 18 and 24 go? Well, remember that the hypotenuse is the longest side. It's the c squared one, which is across on the right angle. We kind of went over some of that first semester. All right, once we got that there, we start simplifying. And so we get 900 equals c squared, and then I simplify that. And I get c is equal to 30, and I want the positive square root because this is a distance. Now, what we could have done is we could have used our Pythagorean triples because we know that this is a right triangle. And so if I can look here and I see that 18, I can say, oh, 18. That is 6 times 3. 24. Well, that's also 6 times 4. Well, if that's 6 times 3 and that's 6 times 4, this is a 3, 4, 5. So if I do 5 times 6, I have the same answer that I would have gotten if I did it with Pythagorean theorem. So does that work all the time? Well, no, not all the time. But this group had a number in common. So if you see at 18 or 24 see some numbers in common, you could look and see, does it really make a Pythagorean triple? And if it's one of the ones that you remember, it'll make the problem easier. It'll at least cut down your numbers. All right, so finding the length of a leg. So here we have another Pythagorean theorem problem. Now, some of you made this mistake on the tests and some on the final exam. You didn't pay attention where your Pythagorean theorem numbers go. So where those number goes makes a difference. So if I look at here, I'm finding a leg. So that could be an A or a B. So I plug in my numbers. 8 is the A part. The x squared is going to be the B part. And the 20 squared is going to be the C. I simplify. Once I get x squared equals 336, remember that because of this second semester, we'll let you use calculators all the time because you're using radicals and stuff like that. You'll have to simplify that. So you'll have to find what numbers go into 336 that are perfect squares. So we simplify this. We get 16 times 21, which means we end up with 4 squared root of 21. We want those answers to be in simple radical form always. All right, and 21 cannot be simplified. So make sure you're preparing for all that. If you have a calculator that simplifies square roots for you, I'm not going to want you to be using that in class, and I'm not going to want you to be using it in homework. You might want to turn that feature off so that you don't get dependent upon it. All right, so this one says identify a right triangle. So triangle has side lengths 85, 84, and 13. Is the triangle a right triangle? And explain why. Well, we know a squared plus b squared equals c squared, and if I can put my numbers in there. Now, you have to pay attention where you put the numbers, because this is the largest number, that has to be the c. The other two don't matter as much. So when I plug those in, I get 13 squared plus 84 squared equals 85 squared. Multiply that out, I get 169 plus 756. And notice I have a question mark there because I don't know if it's equal or not. And then when I simplify that, it does come out to be equal. So therefore, since the numbers work in Pythagorean theorem, it is a right triangle. All right, so using the distance formula to verify perpendicularity of segments. So we're looking to see, is AC perpendicular to CB? Okay, well, the first thing we want to do is we find the length of each piece. So we can do our Pythagorean theorem. So pause this video and practice doing the length from A to C, B to C, and A to B. You need those distances. Use that Pythagorean theorem and get that, and then turn the video back on when you're ready to go. Okay, so let's see how you did. So for AC, you should have gotten a square root of 50. AC, you should have got a square root of 18. And AB, you should have got a square root of 68. So when you have those, all right, then we're going to take those, but now I didn't simplify those. You don't need to simplify them because you're going to square the square roots. And when you square the square roots, you get the numbers without the square root sign again. So 50 squared plus square root of 18 squared equals square root of 68 squared. So when I square those, I get 50 plus 18 equals 68, and I end up with 68 equals 68. So I know that angle C must be a right angle because this worked in Pythagorean theorem. All right, classifying a triangle. A triangle has side lengths 6, 11, and 14. We want to know if it's acute, obtuse, or right. Well, the first thing you want to check is, does it make a triangle? So, does 6 plus 11 greater than 14? Well, that checks. So then it is a triangle. If you don't check to see if it's a triangle, you're going to call something acute or obtuse or right, and it's not even make a triangle. So how do we know which side we're looking? This is the biggest side, so it needs to go in for C. So when I plug this information in, I get 14 squared, 6 squared, and 11 squared. I simplify those. And I simplify again, and I get 196 is bigger than 157. And remember, this is the A side. So which side ended up being bigger? This side, so it's going to be an obtuse triangle. Remember that if the A squared side were bigger, it would be acute. A for acute. All right, so it says the sides and classification of a triangle are given below. The length of the longest side is an integer. That means it's a whole number given. And the value of x says what values of x make the triangle. So we want this to be an acute triangle. We know this is the C part, so this is my A and this is my B. So x squared plus x squared, I got 4 squared. Now this was an acute, which means this side has to be bigger. So that's 2x squared is greater than 16. X squared is greater than 8. So x got to be greater than the square root of 8, which is x has got to be greater than 2 square root of 2. And simplify that square root of 8. All right, and so there, the value of x has to be bigger than 2 square root of 2. Anything less than that would not even make a triangle. Okay? All right, so pause video, try the other one. Okay, so when you're done with this one's going to be an inequality. with two sides to it. It gotta be x gotta be greater than 0, and it's gotta be less than 3 square root of 2 over 2. If you have a problem with that, make sure you ask when you come to class the next day. This one was a fraction when you square rooted it, so that's where you have some issues. All right. Let's move on to our next problem. All right, so it says, find the area of an isosceles right triangle. Leave your answer in simplified radical form. So just real quick a reminder, area is equal to 1/2 base times height. Okay, and so we have our base here, but we don't have our height. And when we put a height into an isosceles triangle, remember that it bisects this, and it forms a right angle, the isosceles triangle. So therefore, this is going to be 10, this is going to be 10, and I need to find height. So I'm going to say 10 or 16 squared equals 10 squared plus h squared. That's 256 equals 100 plus h squared. 156 is equal to h squared. All right, and so this is going to be 4 times 39 equals h. So it's 2 square root of 39 is equal to h. And so I had to simplify that radical there for 156. All right, so area is equal to 1/2. My base is 20. My height was 2 square root of 39. So when I work in this 1/2 and this 2 cancel. So I end up with 20 square root of 39 inches squared. That's my unit. All right, so you can pause the video. You can do the second one here, and then we'll move on from there. Okay, so now that you got this one done, your area for this one should have been equal to 27 square root of 7 centimeters squared. Don't forget those units when they're there. If they're not there, just use the general word units or unit squared. If you have a problem with that, make sure you ask when you come to class. And that's the end of our lesson.